Now, the first thing that we have to know and focus about it in the IGCSE syllabus, it's something called Ohm's law. Ohm is the name of a scientist, okay? In the whole syllabus of the IGCSE, we have two laws that we have to know it, Hooke's law and Ohm's law, okay? Who can remind me about Hooke's law? Hooke's law state what? Hands up. Hooke's law state what, if you remember? Yes, Muhammad, تفضل.
The extension of a spring is directly proportional to the weight, force.
Exact, to the force, exactly. Thank you. Lower your hand. He said the key word here, directly proportional. The same thing here. Ohm's law, when he studied the relationship between voltage and current, he find out, look here, don't draw this. He find out when I bring a cell and I connect it to a lamp, okay? This is the symbol for a cell, this is the symbol for a lamp. The lamp will turn on. If I bring two cells and connect it to the same lamp, okay, the lamp will be brighter. Why? I give it more what? I give it more voltage. Okay, so that means there will be more brightness. That means there will be more current. If I bring three cells, okay, behind each other and connected in series to the same lamp, it will be what? Much brighter. Okay, he did the opposite. He bring one cell and connected to two lamps. Same identical lamps as before. What happened to the brightness?
Distribution of the brightness?
Exactly, much what dimmer. So what that means? There's a relationship between two things if the third is constant. Here, the third is not constant. Here we are talking about one lamp, one lamp, one lamp. Here we add extra lamp. So I'm talking about the same voltage as before, okay? But the current decreases. Why is this? Here there is a relationship between two things. What are these two things? The potential difference, the voltage, and what? And the current. Yes, exactly. Shukran, number one. Okay, more energy, less worker, more what product. Yes, you can say it like this. So what Ohm's law state? The current passes through a conductor like a wire, okay, through a conductor is, what's the key word that we have to write it down? Directly proportional to the PD. What do I mean by PD? Potential difference. I mean by PD, potential difference or voltage. Across mean across the conductor, across it. This is the condition. This is Ohm's law. But what is the condition? When we talk about Hooke's law, we said until it reaches its limit of proportionality. Here, when the resistor is constant, as the resistance or temperature or whatever remains what? Remains constant. So, look here. That means I is directly proportional to the voltage. And also, we know that whenever resistance increases, the current, what will happen to it? Decreases. Whenever there is more traffic in the road, that means there will be less cars pass every second, and you will not choose this way. Okay, the same thing for electricity. Okay, whenever there is several ways, okay, to make the current pass through the wires, we have several wires and several instruments. Whenever the instrument has less resistance, that means the current will pass through it. It will be what? More. Okay, so that means also I is inversely proportional with what? With the resistance. Okay, look here. I is directly proportional to the voltage when the resistance is constant, but I is inversely proportional with the resistance when the voltage is constant. So that means from what we wrote and what we reach here, that means V, the voltage, is directly proportional to I. To remove this sign and put equal sign, we have to put constant, like force, directly proportional to the extension, To remove this sign and put equal sign, I have to put a constant value, and the constant value was what? Was the resistance. So V equal I multiplied by R. V equal IR. This is the Ohm's law in words, in letters. So again, what is V? The voltage, and supposed to be in volt. What is I? The current, and supposed to be in, what's the unit of current? Exactly, ampere. Bravo, A, ampere. Makes R the resistance, and the unit of the resistance, according to the name of the scientist, ohm or omega. This Greek letter, omega, that looks like what? Like this, okay? That looks like this symbol, okay? Tamam? Any question? Okay. Now, this is a very important formula. Every time they bring at least one question about it every year. They bring 1 or 2 questions about it every year.
So what's the formula of resistance?
Resistance? Hey, resistance equal voltage divided by
No, the unit.
ohm, omega, ohm, like this. This is the Greek letter. Ohm, omega. Do you know omega, the watch omega? The brand name? Ohms, okay?
Heard about it.
Greek, yes, exactly. Tamam. So when the current passes through the resistance, some of the electrical energy is converted into what? Into heat inside the resistance, which turns to rise the temperature of the component. So the resistance of the solid conductor increases as the temperature increases, while the resistance of it can be calculated by using the following equation: resistance equal voltage over what? Over current. Or we rearrange this formula to make voltage resistance equal voltage over what? Over current. So actually, we can find that we have several types of materials. Some materials, they obey Ohm's law, and other materials, they don't obey Ohm's law. What that means, some materials, they have constant resistance, and other materials, they don't have constant resistance, and their resistance changes according to some conditions. One of these conditions is the temperature of what? Of the device. Yeah. For example, if you have a laptop or a mobile, okay, and you work a lot of on it, or you play a game, okay, and suddenly it becomes hot, okay, it becomes high temperature, okay, and the fans, for example, if I talk about laptop, the fans start to work and to cool it down. Does the speed of the laptop remains the same or slows down? The speed of the laptop as the laptop becomes very hot, it remains the same or decreases the speed? It becomes slower. Yes, it becomes slower. It's not remains the same. Why that? Because unless you have a supercomputer, okay. Why is this? Because as the temperature increases, the resistance of the devices inside, exactly, the resistance of the devices inside the laptop, okay, becomes hotter, and the resistance increases, make the current pass through them decreases, and that's why the applications, they will have slower working, okay, they will not work as fast as they were, they becomes slower a little bit, okay. So yes, it's similar to Hooke's law. Yes, so we have 2 types of materials. Some materials, that are called ohmic conductors, other materials they called what? Non-ohmic conductors. So ohmic conductors, the resistance stays the same, stays constant. That means the ratio of V over I remains constant. Whenever I change the voltage, the current increases with the same constant value. Okay, so if this is 10 over 2, it will be similar as 15 over 3. It will be similar as 20 over 4. Every time I increase the voltage, the current will increase, but the ratio remains the same. Okay, that's why they called what? Ohmic conductor. But non-ohmic conductor, as their temperature changes, what happened to the resistance? The resistance changes, so the ratio is what? Is not constant. What do I mean by ratio? Look here. For ohmic conductors, if I plot a graph between voltage with what? With current, I will find a straight line, like Hooke's law. Do you remember when there's a straight line? Okay, this is straight line supposed to be what? Straight line if it what? If it's ohmic conductor. That means the gradient of this line, which is V over I, the change of the rise, the change in velocity, the change in voltage, divided by the change in current remains the same value, which is what? R. So R is constant. If I switch the axes, this is the current, and this is the ampere, okay, the voltage, sorry, this is the current, and this is the voltage. Also, the resistance, okay, remains constant, which is equal 1 over the gradient, okay? The slope, which is delta y over delta x, that means delta I over delta v, or I over v, which is equal 1 over r, okay? Also remains constant for ohmic conductor. But for non-ohmic conductor material, which we have many non-conductor materials, okay, their graphs, they will not be a straight line. They will be curved line like this. As you can see, they are not a straight line. What that means the gradient keep changing. The gradient keep changing. And we have in our syllabus 3 different materials that they are what? Non-ohmic, they ask about it. I'll draw 3 of them. Voltage with current. Its graph, it will be going up like this. For filament lamp. What is the filament lamp? Is the lamp that has a small wire inside it that it's very hot, okay? The lamp, the bulb, okay, that has a small thin wire inside it that glows when there is a current pass through it, okay? That's what called filament lamp. It has a curve, a curved graph like this. That means its resistance keep what? Increasing, okay? For thermistors, another device called thermistor, the voltage and the current, they have a graph that changes in the other way, like this. As the voltage and the current increases, its resistance decreases, okay? That's for thermistor. We're going to study it later on in details. Thermistor. And the third device, which is what? Which called a diode, okay? The voltage and the current graph between them, it's a unique device actually, okay? Tamam. Okay, it will not start from 0 as these two. It will start from some value here, okay? Then goes to be curved like this. And this is what the diode. So it will be 0 until certain value, then start to be curved like this. These are the most 3 non-conductor, okay, non-ohmic materials, okay, that we have to study them, okay? Mashi? Any question? But that means, ya shabab, I need a device here, this one, that keep changing the voltage or keep changing the current. Now you have it in your houses and you have it in your cars, even in your mobiles and laptops. Let me show you something. For example, someone have in his house a chandelier that has a switch that is rotating switch. And whenever you are rotating the switch, the brightness of the lamps on the chandelier becomes brighter or dimmer. You turn it on or you turn it off. When you turn it off, there's no light. When you turn it on, the brightness keeps increasing until the maximum brightness. Who has like this type of lamp that you can control how much bright it is?
I've seen it before.
You never see it before. Okay, you see it before. Okay.
No, I have seen it before.
You have the same thing on your cars. You rolls the controller of the volume of the loudspeaker to increase the loudness or reduce the loudness. What you are going to do here, you are changing the resistance of the whole circuit. As the sound or the light becomes brighter, becomes louder, you make the current increases. So as the current increases, that means you are decreasing what? The resistance. So as the resistance decreases, the current will increase because they are inversely proportional. And this device called variable resistor. So this is one of the devices that this is how it looks like, one of the ways. They call it what? Variable resistor. Another way to draw the variable resistor is like a resistor, but has an arrow passing through it like this. So this is the variable resistor, okay, or rheostat. Okay, we can control by it. What does it do? Control the current by changing the resistance. By changing the resistance. Okay, we're going to talk about that in details later on. Okay, so I'm giving you small information here, small information there. So then we build up the whole thing about the electric circuit. Yes, Marwan, تفضل.
I didn't understand what is the use of variable resistors.
The variable resistor, the use of it to control the current. I can increase or decrease the current, okay, by changing the value of the resistance in the whole circuit or by itself. Because whenever we are going to study it later on in details. Whenever I increase the resistance in the circuit by I increase its resistance, the current passed through the circuit will be what? Will be less. So the reading of the ammeter will be what? Will be less. So if I want to do this experiment, okay, in the right way or the left way, it doesn't matter. I want to find the resistance of the device, of the variable resistor or of a wire or whatever, okay? What do I need? I need two instruments to measure. I need to measure the current and I need to measure the potential difference before and after it. So if I plot the graph between the voltage by the voltmeter and the current by the ammeter, I'm supposed to get what? A straight line. The gradient of this line can be the resistance or can be 1 over the resistance according to what is on the x-axis and what's on the y-axis. Okay? Tamam? Okay. So what actually the resistance is not included in the syllabus. The definition of it is not included in the syllabus. But I would say it's a device or something, okay, that resists the flow of charge through it. And whenever the resistance is higher, the current will be what? Lower, okay? تمام. So, yes, exactly, عبد الرحمن, صح. مروان مش عارف ليش هيك متفاجئ بس الفكرة. So, what is the resistance? The oppose of the flow of charges. So what that means? That means as the resistance increases, the current what? Decreases. Or as the resistance of any device decreases, the current, what will happen to it? Increases. Okay? And the resistance of any wire, we are talking about wires here. Okay? The resistance of any wire depends on several factors. What are these factors? Number one, the length of the wire. So, for example, if I want to turn on the television here, okay, I will not connect a wire from next building, okay? Why? Because whenever the wire is longer, that means it will have greater resistance. So that means the current will reach the television, it will be less. Maybe it will not work properly, okay? It will not work as it's supposed to be. It will not be normal brightness. It will be dimmer a little bit, okay? So that means, okay, number one, the length of the conductor, R, is directly proportional to the length. As the length of the wire increases, the resistance of the wire increases. What that means? What that means? If the length is increased, multiplied by 2 twice, that means the resistance of the wire will also increase, multiplied by 2 with the same factor. So for example, if a wire 1 meter long has a resistance of 20 ohm, and for example 1 meter wire long, it has a resistance of how much? 20 ohms. If I bring another wire 2 meter longs, okay, how much the resistance of it will be? Yeah, send me on the chat how much the resistance of it will be. 1 meter 20 ohm, 2 meters, how many ohms it will be? Exactly. شكرا يا محمد. شكرا يا ليث. Bravo. It will be 20 what? 20 ohm. 10 meters long. 10 meters long. How much the resistance it will be? 10 meters long. How much the resistance will be? شكرا يا شباب. Bravo. 200 ohms, etc. Okay. So that means the resistance of any wire depends on, number one, the length of the conductor. Number two, the cross-section area. Number two, the cross-section area. That's why the air-conditioned wire, it's approximately this thickness, but the laptop charger is this thickness. It's very thin. So that means I don't need that much current for charging the laptop. That's why the current is thin. So that means it has high resistance. But I need a huge current, so I need less resistance to make the current pass through the air condition. I need what? A thick wire. So that means the relationship between the resistance and the cross-section area are what? Inversely proportional. What that means, inversely proportional? It means as the area is increased, multiplied by 2, the resistance will what? Decrease divided by 2. كيف يا أستاذ؟ For example, خلينا نفرجيكم. هلا أنا هون here we was talking about length with what? With the resistance. Okay. Here I'm going to talk about what? Cross-section area with what? With the resistance. Okay. For example, if I have a wire that has a cross-section area 12 millimeter square, and its resistance was how much? Was 100 ohm. Was how much? 100 ohm. If I double the cross-section area, if the cross-section area now is double, it's thicker, it's 24 millimeter what? Square. How much will be the resistance of this wire? I'm talking about same wire, same material, for example, copper. Okay. In this situation, how much the resistance it will be? Check your answers. Bravo. Thank you, Layth. Thank you, Muhammad. Yes, it will be less. It will be what? 50 ohm. If I make it what? Also double. Okay. So for example, if I make it 48 millimeter square cross-section area, how much the resistance now it will be? Yes, tell me. In this situation. Thank you. Bravo. It will be how much? Excellent. 25 ohms. Why? Because look here. Look here. I multiply it by 2. Here I divide it by 2. Here I multiply it by what? 4. Here I divide it by 4. So they are inversely proportional. They are what? Inversely proportional. Now, usually all the wires, hold on, Marwan. Usually all the wires, if I bring any wire and I cut it by a scissor, it has what? A circular cross-section area. It has what? A circular cross-section area. And we know that. You know that. Okay, the area equal what? Pi r square. That means it's equal pi diameter square over what? 2 square, which is what? Which is 4. That means as the thickness of the wire, the diameter or the area, the radius is doubled, what happened to the area? نعيد مرة ثانية السؤال. As the radius increased, multiply by 2. What will happen to the area? As the radius is doubled, multiplied by 2. What will happen to the cross-section area of the wire? It will increase, multiply by how much? It will increase, multiply by how much? Multiply by 4. Why 4? 2 square. It will increase, multiply by what? 2 square. That means the resistance will increase or decrease? Excellent. That means the resistance will decrease by how much? Divided by 2 square, which is what? Which is 4. Bravo. So again, let me give you another example like this one. Okay. Let me give you another example like this one. We are talking about radius and we are talking about resistance. Okay. Now, For example, if I have 4 millimeter what wire, okay, and this 4 millimeter wire, okay, 1 meter long, for example, of copper or whatever it is, it has a resistance of how much? 60 ohms, okay? It has a resistance of 60 ohm. Now I bring a wire of 2 millimeter radius. 2 millimeter radius. That means the radius is now halved. What happened to the resistance? The resistance will increase by how many times? Twice or twice square? Twice or twice square? Twice square. That means it will be how much? 240 multiplied by 4 ohms. Okay? Good. But if I bring a wire with the radius or diameter of 8 millimeter, okay, what happened to the resistance in this situation? It will be less than 60. Less than 60 by how many times? From 4 to 8, I double the radius. So how much the new what resistance? It will be divided by 2 square. How much 60 divided by 2 square? Excellent. It will be what? 15. So that means the relationship, thank you, Shabab. Y square, because there is a square in the formula, pi r square. So when we increase or decrease the diameter or the radius, the area will increase or decrease by the same factor, but square. That's why there is square. Okay? So when the area is increased, for sure the resistance will what? Will decrease by the same factor. So if the area is increased by 2 square, that means the resistance will decrease by what? 2 square. Good. Any question about this so far? We're going to re-explain by answering questions, okay? Tamam? Okay. So we said that the resistance, yes, Marwan, تفضل.
I want to understand, is resistance a good thing or a bad thing?
The resistance is not a good or a bad thing. It's something that we use it to control how much, what current do we need? How much current do we need? Okay. If the resistance is low, that means the current will be high. If the resistance is high, that means the current will be low. So the device that I wanted, does it need a high or a low resistance to a high or low current to work on, to turn on normally? If it needs a high current, that means I need to make its resistance low, and vice versa. If it needs a small amount of what current, like the mobile, I need to charge it with low current, that means I will not use that thick wire. I will use what? Thin wire. But the air condition, since I need a lot of electricity, I will connect it with what? A very thick wire. Okay? Because it needs more electricity. So number one, we talk about what? We talk about the length of the conductor. Number two, we talk about the cross-section area. Number three, they rarely ask about it, okay? Only when they ask about thermistors, about temperatures, okay? Here we have three different situations, okay? For conductors, as temperature increases, resistance increases, okay? They rarely ask about it, okay? Number two, for insulators, as the temperature increases, resistance what? Decreases. So that's why when a fire starts, okay, the resistance of the insulator, of the insulation around the wires or around any electrical wires or electrical component, okay, it starts to melt or start to increase the temperature, there will be current pass through it because it has low resistance. Number three, for semiconductors, and we are going to talk about one type of semiconductor which we mentioned before, which is the thermistor. Okay, as the temperature increases, the resistance also what? Decreases, so it becomes a good conductor and allowed current to pass through it, the thermistor. Okay, good. Now, from number 1 and number 2, we said that resistance is directly proportional with the length, inversely proportional with the area. So to remove this sign and put equal sign, okay. Unfortunately, مش عارف شو اللي صار here. I don't know what's happened. Okay, all the things that I was writing it here disappear. I don't know what's happened. Okay, طيب. So this is the last thing, Marwan عم بيبكي. The resistance, okay. No, I didn't open a new file. Something wrong happens with the laptop. So the resistance directly proportional with the length and inversely proportional with the cross-section area. So that means the resistance, okay, equal constant value multiplied by length over what? Over the cross-section area. Now this formula is not included in our syllabus. This formula is not included in our syllabus. And this thing that I wrote it as K, they call it what? Resistivity, and it depends on the material itself. But Ustad, why you give it to us? Now, the idea that they ask about something that depends on it, not about the formula. How they ask? When they say a question about we switch the wire with a different wire, but same material. Or same element, copper, aluminum, whatever. Okay, that means this constant, which we call resistivity, and it has Greek letter rho, okay, this one, or K, doesn't matter, remains what? Remains constant. So rho, which remains constant, it will be equal, let's put it as a subject of the formula, okay? It will be equal to what? R times A over what? Over length. So the ratio of this one remains constant. طب كيف السبب دي نجاوب عليها الأسئلة؟ They bring questions about it in two different ways. They switch the wire, so R1, resistance for the first wire, times the cross-section area for the first wire over length of the first wire equal resistance for the second wire times the cross-section area for the second wire over the length of the second wire. This is the first formula, okay? You can use it. Or if they ask about not area, they ask about diameter or radius. The formula, it will be what? Resistance for the first wire multiplied by radius of the first wire square. Why square? Because the area equal pi r square, okay? Over length of the first wire equal resistance for the second wire multiplied by radius of the second wire square over what? Length of the second wire. These are the two formulas that I want from you to understand and memorize when they ask about resistors that I switch these wires with different length or different cross-section area, but it's still same material or same what? Element. Good. This is the last question for today. I know it's a lot of informations, okay, and there is more, okay. Later on, we are going to make a whole revise about everything, okay, and you realize that it will be, okay, a very easy topic, the electricity, okay, and every year they bring questions about it, minimum 6-8 marks about it, and every year this question you can you can get the whole mark of it, inshallah. Okay, look to here to this question. Two conductors A and B are made by same material. I can use one of these equations, okay? The length of wire A is twice the length of wire B. So length of wire A equal twice the length of wire B. This is the first information. The cross-section area A is 1/3 of the cross-section area of B. So the cross-section area of wire A is what? Equal the cross-section area of wire B divided by how much? Divided by 3 is 1/3. Okay? And the resistance of A is how much? 120 ohm. The resistance of wire A equal what? 120 ohm Find the resistance of wire B. They ask about the resistance of wire B. Now, which equation I will use? The first one, okay, or the second one? Which equation I will use? The first one or the second one? Yes, Laith. Why I will use the first one? Because it has area, not what? Radius or diameter. Now look how I'm going to answer this question in a different way. What I'm going to say. I have two wires, A and B. I have the informations about length, informations about area, informations about what resistance. Wire A is twice the length 2L, while wire B has length L. Wire A has a cross-section area A over 3, okay, while the cross-section area of wire B is A. The resistance of A is 120, while the resistance of B is unknown. They ask about it. So as Laith and Sandra and Sidra, okay, they told me that I will use the first equation, so I will say that the resistance of A times the cross-section area of A over the length of A equal the resistance of what? Wire B times the cross-section area of wire B over what? Over the length of wire B. I will substitute these values from this table here. How much the resistance of wire A? 120 times. How much the area of wire A? Area over 3 over. How much the length? It's 2L equal. How much the resistance of wire B? Unknown, R or X, whatever, times. How much the area of it? A over the length of it is L. So by cancelling A with A and L with L, what I will get? 130 times 1 over 3 over 2 equal what? R. By using calculator, the resistance of this wire B is how much? 20 ohms. I know it's complicated. It's a little bit harder. Actually, there are questions harder than this, but this is the first time that you answer like these type of questions. So that's why it's a little bit confusing. Okay, but when we practice more on this type of questions, you will find it not that hard. It will be easy. Any question? Any question? Okay, Allah ya'tikum al-afiyah. That's it for today. Have a nice day. If you have any question, you can stay online. If you don't have a question, you can leave.